Okay, in this video, we're going to be talking about arithmetic sequences. Okay, so firstly, a sequence is just a list of numbers. They don't need any rhyme or reason. It could be like 5, 6, 7.94, 16, random ones like that. But the arithmetic here, it specifies that there must be a common difference, which is called D. A common difference here that we see is just 1. It's what you add or subtract every time. So 1, 1, 1, add 1, add 1, so on. That's the common difference. That's what makes this sequence arithmetic. There's always a common difference. Okay, so since this thing is 1, we say that D here, the common difference, is equal to 1. If we had subtracted 1, like if it was 3, 2, 1, then D is equal to -1. So we're subtracting 1 every time. Okay, moving forward. A student receives a scholarship that increases by $200 every year. If the first year scholarship is $1,000, how much will the scholarship be worth in the sixth year? Okay, so let's just write out his starting amount, which is $1,000. $1,000, comma, and in the second year, we just add 200 to that, so 1,200. One more time. Third year, 1,400. Fourth year, 1,600. Fifth year, 1,800. In sixth year, $2,000. So scholarship is going to be worth $2,000. And notice what we did here. Each time we were just adding 200, 200, 200, 200. And there's a way to write this mathematically. When we're just adding or subtracting, we can use a recursive definition, which is basically just describing mathematically what we did here. We use these braces. We just define our first term. So a of 1 refers to the first term, a of 2 is the second term, so on. So to define the first term, that's 1,000 here. And then next we're going to define what are we doing to this 1,000. Okay, so let's say we have some term n. It's going to be just equal to the previous term. So a of n minus 1, that's the previous term. And we add 200. That's how we would define the sequence recursively. So just to recap that, we define where we start, and for the rule, we take the previous term and add or subtract the common difference. Okay. Now for this next one, let's do it again. Find the seventh even number. Let's start out with the first one, which is 0, 2, 4, 6, 8, 10, 12. Okay, so we're done with the sequence. But let's say you don't want to find the 100th term by adding, and adding. And so you can find a pattern here. Okay, so here we added the common difference 1, 2, 3, 4, 5 times when it was the sixth year. So we did it 5 times here, which was 1,000 plus 5 times common difference, which is 200. This got us our final answer. And for this one, we added the common difference 1, 2, 3, 4, 5, 6 times. So 0 plus 2 times 6. If you're really astute, you'd see that this 6 is 7 minus 1, and this 5 is 6 minus 1. And that actually matches up with the formula for the arithmetic sequence. This is called the explicit formula. If you don't want to use this recursive one where you just add, or subtract, you can use this explicit one, which tells you directly what the value of a given term will be. And it matches up with what we did here. If we want to find the seventh even number, it's going to be a of 7. That's equal to the first term, 0 plus the difference, which is 2, and number. So we want the seventh one, so we subtract 1. That's equal to 2 times 6, which is 12. and these answers match. So when we're dealing with larger numbers, like let's say that 1000th term, this one's a lot better. It's the explicit formula. Okay, let's use the explicit formula for problems here. An arithmetic sequence has a first term of 2 and a last term of 50. If the common difference is 4, how many terms are in the sequence? Okay, so this is what I would do. Let's refer to our formula. A of n is equal to the first term plus d times n minus 1. And let's plug in what we do know. We know last term is 50, and that the first term is 2. The common difference, which is d, plus 4 times n minus 1. And we're trying to find how many terms are in the sequence. So we're just trying to solve for n here. So let's do that. Subtracting from both sides, you get 48 is equal to 4 times n minus 1. You could distribute both sides or divide by 4. So 12 is equal to n minus 1, which means that n is equal to 12 plus 1, which is 13. It means there are 13 terms in this sequence without needing to list them all out. Okay, time for the next one. In an arithmetic sequence, the third term is 14 and the seventh term is 38. What is the rule for the sequence? Okay, so let's write the third term in terms of that formula. So a of 3 is equal to, okay, so the first term, we don't know that. Let's just call it a of 1. Okay, add d, okay, we know that n is 3, so let's just plug that in. 3 minus 1. And we do the same thing for the seventh term. A of 7 is equal to a of 1 plus the same difference. And n is 7, so 7 minus 1. Okay, and since these two equations are linked, it's not too far-fetched to set this form a system of equations. Okay. Let's replace a of 3 with what they told us it's equal to. A of 3 is 14. And the seventh term is 38. Okay, and if you're uncomfortable with this a1 and d, you could just replace it with x and y if you're familiar with that. Well, let's keep simplifying this further. 3 minus 1 is 2, so this turns into 2d. And this one turns into 60. Okay, nice. And if you recall from Algebra 1, if you have a variable like this, you can subtract the two equations. Okay, and now 14 minus 38, that's going to be equal to negative 24. Negative 24. These a of 1s just cancel out, it's just a of 1 minus a of 1. So negative 24 is equal to 2d minus 60, which is negative 4d. Divide both sides by negative 4. The difference is equal to 6. Okay. And now that we know d, let's just write it down to the side here. D is equal to 6. And we can plug it into this first equation to find the other variable. So d, 6 times 2. So this turns into a 12. A of 1 plus 12 is equal to 14. So that means that a of 1 is equal to 2. Okay, and now with these two facts, we can write the rule for the sequence. A of n is going to be equal to the first term, which is 2. 2 plus the difference, which is 6 times n minus 1. And we're done for this problem. Okay, but now here. When you begin to replace the commas with plus signs, you're dealing with a series. To find the sum of an arithmetic series, use the following formula. The sum of the first n terms is equal to number of terms divided by 2 times the quantity, the first term plus the last term. Okay, just clarifying a bit what it means by series here. If you have 1, 2, 3, 4, 5, if you replace it with plus signs like 1 plus 2 plus 3 plus 4 plus 5, this bottom one is going to be a series because of the plus signs, but the top one is going to be a sequence. Okay, so let's use it for this problem. The first term of the arithmetic sequence is 6, and the last term is 42. If there are 10 terms in total, what is the sum of the sequence? Okay, so this formula is useful because instead of just adding 6 plus something plus another thing plus and trying to do all that addition, we can just use the formula. Okay, so the sum of the first n is equal to n divided by 2, parentheses, a of 1 plus a of n. Okay, so let's use information they tell us. There are 10 terms in total, so this n of 2 turns into 5, 10 divided by 2, times the first term, which is 6, plus the last term, which is 42. Okay, so we're left with 48 times 5. Let's see what that is. Okay, 8 times 5 is 40, 34, 240. Alternatively, you could have multiplied by 10 and divided by 5. Okay. So that one was easy. The sum is 240. Now for the next one. This one's a little harder. If the sum of the first n terms of an arithmetic sequence 3 is 325, the first term is 10, and the common difference is 5, what is the value of n? Okay, so again, I see sum, so I would just immediately write down the formula. So the first n terms is equal to n divided by 2 times a of 1 plus a of n. Okay, so the sum of first n terms is 375, so let's split that in. Okay, substituting, we get 25 here. The first term is 10. Let's put that in for a of 1. Okay, and still here, we don't know what a of n is. Let's see if we can find a way to define a of n. Okay, so we know that a of n has to be a term of the sequence. So we can write it using the information we know. So the first term is 10. We're calling, just write it down here for reference, it's equal to a of 1 plus d times n minus 1. Okay, in this case, first term is 10, so a of 1 plus d, which we do know, is 5 times n minus 1. Okay, now we can erase this. Okay, now we know what a of n is. We can put it back into here. Okay, we're gonna need some more room. Space. Okay, when this is a of n, so we can put it back in. This is gonna be 20 plus 5n minus 5. Okay, so this is 15 plus 5n. That's what all of this simplifies to. Okay, and since here we have a fraction, and over 2, I would multiply both sides by 2, just to not deal with that. So 325 multiplied by 2 is 650. So 650 is equal to n times 15 plus 5n. For this one, I'll use a graphing calculator. You could use a quadratic formula or try small values of n, since this is an arithmetic sequence, and you'll get term numbers. Okay, so 650 is equal to x times 15 plus 5x. Okay, we get that x is equal to 10. So that means n is 10. And the value of n is 10.